Algebra 2 Trigonometry Section 3.9. Make sure before you start this video that you're actually working on those math review questions. They're focused on the sum and product of roots lesson from Section 3.8. So today we're going to talk about factoring by grouping. Factoring by grouping is a method that's utilized to help factor out cubic equations. Notice the two examples I have on the board, examples 1 and 2, are both cubic equations. They have an x cubed as their highest exponent. Now, factoring by grouping can sometimes be referred to as a double GCF. What do I mean by a double GCF? Well, let's take a look at this first example. X cubed minus 3x squared minus 4x plus 12 equals 0. I'm going to take this left side, because it's equal to 0, like many of our equations, and I'm going to split it up right down the middle. Notice on the one side I have x cubed minus 3x squared. On the other side I have negative 4x plus 12. If I was to take this left side, x cubed minus 3x squared, and factor out just the GCF there. It has an x cubed, it has an x squared, the GCF would be x squared, parentheses, x minus 3. Again, make sure to check that by doing distributive property. On the right side, I have negative 4x plus 12. The GCF in this case would not be 4, it would be negative 4. Notice it starts with that negative sign. So if I take a negative 4 out, I'm left with x. And 12 divided by negative 4 is negative 3. Now, hopefully you've noticed that your two binomials in the parentheses here turned out to be the same thing. They both turned out to be x minus 3. So I'm going to write x minus 3 as one of my factors. My other factor is going to come from the two GCFs. In this case, x squared and negative 4. Notice the first factor is x squared minus 4. The second factor is x minus 3. Just one x minus 3, not an x minus 3 squared. So again, those two GCFs became one binomial. The second GCF, the two binomials is the other factor, x minus 3. Notice they were the same. They have to be the same, x minus 3 equals 0. Now I can solve this like a quadratic equation. Do a t-chart. X squared minus 4 equals 0. X minus 3 equals 0. On the left side, I can turn it into x squared equals 4. It's got a square, so I square root. X equals plus or minus the square root of 4. Don't forget the plus or minus sign. So x equals plus or minus 2. On the right side, x will equal 3. So in the end, I will have 3 solutions for this cubic equation. My x values will be negative 2, positive 2, and positive 3. Over here, we see a second example. I'm going to follow the same exact method. I'm going to start by first splitting it right down the middle. Then, just like I did in the previous problem, I'm going to factor out the GCF from each side. Remember, the GCF can be a number, it can be a variable, it can be a combination of numbers and variables. We see on this left side, notice they both have x's, and the lowest exponent is x squared. So it will be x squared times 2x plus 7. On the right side, 8x plus 28. They're both positives, I don't got to worry about signs, but obviously the number that goes into 8 and 28 is 4. Not 8, 4. Positive or negative? Positive. put a plus sign. Parentheses. What's left? 2x plus 7 equals 0. Now, just like in the previous question, I can see that 2x plus 7 and 2x plus 7 are the same exact binomials. I'm going to take them and combine them into one. 2x plus 7. On the other side, I'm going to create a second binomial from the two GCFs. So the x squared and the positive 4. Notice this is different from the previous question where I had a negative 4. Here I have a positive 4. But just like in the previous question, I now have two binomials. Notice, of course, though, this has got an x squared in it. So since it's like that previous question, I'm going to do the same thing. It's set equal to 0, solve by factoring. Sorry, solve by setting equal to 0. On this side, we get x squared equals negative 4. So x squared equals plus minus the square root of negative 4. It's a negative under a radical. So x is equal to plus or minus 2i. Yes, we can get imaginary values for our solutions. On this side, we have 2x equals negative 7, so x equals negative 7 halves, or negative 3.5, whatever you choose. Notice again, now I have the same thing where I have three solutions. I have negative 2i, positive 2i, and negative 3.5, or negative 7 halves, whether you choose to write it as a decimal or a fraction. So that is factoring by grouping. Be sure to work on the extra examples with this. But of course, we're not done. There's more. Now, if you flip your page over, on the back you'll see factoring the sum and difference of two cubes. This is very similar to dots, difference of two squares, except now we're talking about cubes, and we're going to incorporate both sums and differences. Remember, your cubic numbers, 1, 8, 27, 64, 125, 216. Make sure you're knowing those numbers. Let's take a look at 3 examples to show how we could factor each one of these. So in the first one, we have a sum of two cubes. We have x cubed plus 8. If I was to take each one of these and do a cubic root, I'm going to do the cube root of x cubed, which is x. I'm going to do the cube root of 8, which is 2. Now, according to the pattern that is shown on the top of your page, you will see that if I take these two numbers, x and 2, x is like my a value, 2 is like my b value. So I'm going to do a plus b in parentheses times a squared minus ab plus b squared. So if I substitute into that method, that would make it x plus 2 times x squared minus 2x plus 4. That would be the factor of it. Notice I do end up with a binomial and a trinomial. This trinomial is unfactorable. Many people will want to factor it. Unfortunately, it is not factorable. This is the pattern, however, you would use in any of these. Notice in number 8 now, it's very similar, except it's a difference of two cubes. I'm still going to follow that same exact method. I'm still going to take each term here and do the cube root. So I'm going to do the cube root of 216m cubed, and the cube root of 1. Correction, -1. What does that turn into? The cube root of 216, of course, is 6, and the cube root of m cubed is m. What is the cube root of -1? Well, you could always put that into your calculator, but it's simply -1. Notice now that gives me a negative value for my b. Again, this was like my a, this is my b. Using now this formula, if I was to just substitute in, that would be the same as 6m minus 1. Which again, think, the cube root of the 216m cubed and the cube root of the -1. Times, I'm going to take the 6m and I'm going to square it, so that's 36m squared. I'm going to take the two numbers and multiply them together with a negation. So 6m times -1 is -6m, but if I negate that, that's positive 6m. And then I'm going to square the -1, making it positive 1. And there's my difference of my two cubes. Lastly, if we look at question like number 9, 4 and 32, those are not perfect cubes. 4 is a perfect square, but 32 is not a perfect cube. So what do I do? Well, in this case, I'm going to have to utilize a GCF, which in this case, for 32a cubed, the GCF would be 4. If I take a 4 out, I'm left with 1 plus 8a cubed. Now, just like I did in the previous problems, I'm going to take this 1 plus 8a cubed, and I'm going to do the cube root of each term. So I'm going to do the cube root of 1, which is 1, and the cube root of 8a cubed, which is 2a. Now remember, this is like my a term, this is like my b term. Plug it into that a plus b times a squared minus ab plus b squared. What does it become? 1 plus 2a times 1, because 1 squared, negative ab, so -1 times 2a is -2a, plus b squared, so square the 2a squared, that would be 4a squared. And I'm done. Wait a minute. Remember I have this GCF of 4? Make sure to include that as part of your answer. And there I have 3 examples of factoring the difference or sum of 2 cubes. Again, follow that formula. Be aware of GCF. Follow the steps and patterns that are on your packet. Make sure that you are trying all the examples. Make sure you're working on the classwork page, the homework page, because you will be receiving an exit ticket on this material when I return. If you have any questions, be sure to email me. Check things online. Practice these questions. Make sure you also do section 3.8. You do have a test coming up. I know you had fun. I did too.